So let's start with Gulmina, the first question. Yes, Gulmina.
A ball is thrown from a point P, which is at ground level, as illustrated in Figure 2.1. The initial velocity of the ball is 12.4 meter per second at an angle of 36 degrees to the horizontal. The ball just passes over a wall of height h. The ball reaches the wall 0.17 seconds after it has been thrown. Assuming air resistance to be negligible, calculate the horizontal distance of point P from the wall.
Okay, so listen, whenever they give you this sentence that the air resistance is negligible, then you have to use all the concepts of kinematics to solve that question. Okay, if there's no such a sentence given, then they may ask you to solve using the different concept like the energies and the forces concept, right? Fine. So they are saying the initial velocity of the ball at an angle is 12.4. So yeah, and at an angle of 36, fine. Okay. What they're asking? Okay, yes. Yes, Gulmina, क्या करेंगी? They're saying horizontal distance. Yes, any idea? Any idea? Gulmina,
Horizontal distance के लिए speed is equal to distance over time you spent there.
और ये क्यों? Why is that? And why not the equation of motion?
Uh,
Because we have the constant speed in the horizontal motion, right? We don't have any resultant force in the horizontal motion. That's why we are just using a velocity or speed is equal to distance upon time, right? Getting? Fine.
okay, sir.
So now you have to find the horizontal speeds first, and they gave you the time. Okay, so this time will be same for both the vertical and horizontal motion. So now, what will be your horizontal component of the velocity, Gulmina?
The horizontal v cos theta.
Good. So 12.4 cos 36. Okay. So 12.4 cos 36 into 0.17. Okay, just calculate the value, please. इब्राहिम आ गया? इब्राहिम इब्राहिम इब्राहिम, हाँ इब्राहिम आ गया। कैसे ब्रो, सब खैर खैरियत मजे में?
यस सर।
ओके। कहाँ था भाई, इतनी लेट आ रहा
सॉरी सर।
है स्कूल स्कूल लेट जाते हो?
हाँ जी सर।
स्कूल स्कूल से कब आते हो, 3-4 बजे तक? या शाम शाम के स्कूल है?
नहीं, शाम की स्कूल नहीं है सर।
हैं? फिर तो बढ़िया जिंदगी है यार। अच्छा, कितना आ रहा है गुलमीना,
Sir,
कितना आ
it's
रहा
1.71.
है? 1.71।
71.
Okay, just 1.7, okay fine. Okay, move on to the other part. Okay, the height of the ball. Yes. So for the height, they are asking you to solve the vertical motion, right? The height is actually the vertical distance. Okay. So how many things do we have for the height? So you have, h is the s, the displacement, the vertical displacement is h. Okay. Initial velocity, what is the initial vertical velocity, Gulmina?
V sin theta.
Perfect. So 12.4 sine theta, sine 36. Okay, fine. So we have that vertical velocity 12.4 sine 36. Okay, fine. Since it is moving up, so what would be our acceleration?
Positive 9.81.
अबे नेगेटिव, ऊपर जा रहा है ना ब्रो,
Oh,
अगेंस्ट द
हाँ,
ग्रेविटी
sir.
मूव कर रहा है, राइट? And the time taken to reach the ball to the wall is 0.71, right? So this should be used for, or this can be used for the horizontal distance and for the vertical distance, or horizontal motion and vertical motion, right? So the time given is 0.17. Fine. Which equation of motion you use? I think
2 as is equal to v squared.
है
minus u square.
bro, t दे रखा है ना.
Um,
They give you t, and the equation you told me you're telling is haven't any t. So ut plus half at square. Just go with that. Okay. So s is equals to
sir, is
u
it compulsory? Is it
2.
compulsory to use t?
Bro, other than that, like if you use 2as is equals to v square minus u squared. So okay, fine. So you have your initial velocity, you have 2, you know the 2, you have that a you are interested in s, but what will you take as your final velocity?
Oh, okay, sir.
Yes. Okay, you may say that the final velocity could be 0, maybe. Assuming that this is a maximum height reach, but this is not the case. Okay, they didn't mention any such thing, right? As this is the maximum height that the ball reach. Okay, so this is just a random height. It is not a maximum height. It is also possible that if the wall may not be there, then the ball may go like this. Okay, and there should be a maximum height greater than h. Okay, so that's why. Clear? So S is equals to UT. So U is 12.4 sine 36. T हमारे पास है 0.17, and we have 1 over 2 into minus 9.81 into T, which is 0.17 squared. Okay. निकाल दो प्लीज कितना आ रहा है. Yes, how much?
1.1.
You are saying 1.1. That is perfect. Okay. So I got you. Let's move on, please.
A second ball is thrown from point P with the same velocity as a ball in A. For this ball, air resistance is not negligible. This ball hits the wall and rebounds. On figure 2.1, sketch the path of this ball between point P and the point where it first hits the ground.
Hmm. What will be the difference that the air resistance will create? Yes. Any idea? Any idea? No idea.
Will path of ball Zada, like the angle is going to be shorter?
No. Like you are launching the ball, so you can adjust the angle, right? So, it is in your hand, right, to manage the angle.
I mean,
Air
like,
is like air resistance won't affect the angle. Huh? You may say that air resistance may affect the hitting angle, maybe.
hitting angle, like at which point it hits the
Okay.
wall.
Okay, fine. Actually, now, whenever there's a air resistance, so air resistance will always reduce the horizontal distance and the vertical distance. Okay. So if without the air resistance, the ball is getting this much height, so with the air resistance, the ball will get a lower height. Okay. Maybe like that, and then rebound to this point. Okay. Clear? Any problem?
No, sir.
Perfect. Um, let's move on to this part. इब्राहिम करवाएगा. इब्राहिम आजा बच्चे. इब्राहिम करवा दो ये क्वेश्चन.
Distinguish between scalar quantities and vector quantities.
क्या होती थी भाई?
Uh, Scalar quantities. हाँ जी
हम्म.
सर.
यस यस यस, बोलो बोलो बोलो.
Scalar quantities have only magnitude, and vector quantities have magnitude and direction.
वेरी गुड यार. सो स्केलर क्वांटिटी है ओनली मैग्नीट्यूड बाय. आगे आ जाओ. यस इब्राहिम आगे चले आओ.
Uh, Kinetic energy,
ओके.
mass. Power.
Scalar. So you are saying kinetic energy, mass, and power. Okay. Weight, force, weight, and acceleration all are a vector. Okay, fine. Okay. Move on, please.
The stone is thrown with a horizontal velocity of 20 meters per second from the top of a cliff 15 meters high. The path of the stone is shown in figure 1.1. Air resistance is negligible. For this stone,
Hmm.
calculate the time to fall 15 meters.
Fine. So which motion you will consider, the vertical or the horizontal?
The vertical.
The vertical. Very good. So um, vertical motion. Okay. For vertical motion, will you use the equation of motion or just choose speed is equal to distance upon time? Yes, quick.
Speed is equal to distance upon time.
No, bro. Vertical motion contains the gravity, right? Vertical motion is influenced by the gravity, right? And gravity causes the acceleration, okay? So vertical motion is the constant acceleration motion, okay? So you have to use the equation of motion and not the distance over time, right? Getting?
Okay, sir.
Perfect. So for the equation of motion, we have five different variables, so at right? S, U, V, A, T. So what is our displacement? Yes, Ibrahim, quick.
15,
Good. And what is our initial velocity?
0,
And why?
because it's at rest.
Wait. Because it is saying that you are throwing the object horizontally, okay, right? It is not at rest, okay. Like if it is rest, then it just fall down and not go in this direction. Are you getting right? समझता है?
Yeah, and vertical motion is zero.
Yes.
It's vertical motion.
Hmm. Perfect. So what will be our final velocity? Final velocity is unknown. What will be our acceleration?
9.81.
9 point with a positive sign, okay. And the time is what we are interested in, okay. What equation we use? Yes, initial velocity, final displacement s or t. You can use s is equals to ut plus half at square. इब्राहिम याद नहीं हुई अभी तक? चलो
No, sir.
कोई
Check
बात
करो.
नहीं, हो जाएगी हो जाएगी हो जाएगी. अच्छा जी आ जाओ. So r u is zero, so this whole factor will be zero. The 15 is displacement, and when you move to that side, so it will be just multiplied by 15 and just divide that by 9.81 and root it, okay. इब्राहिम समझ में आया? सिंप्लीफिकेशन समझ में आई इब्राहिम?
Yes, sir.
परफेक्ट. निकाल दो प्लीज, कितना बनता है कैलकुलेटर रहेगा?
One point
1.75 आ रहे sir.
1.75. So just take 1.8. Okay, fine. Move on, please.
But it's 1.748.
Okay, then just
It's
1.7. Fine, 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 fine.
okay. 1.75.
Yes.
Calculate the magnitude of the resultant velocity after falling 15 meters.
Okay. Ibrahim, what is meant by the resultant velocity here?
V, sir.
What will be our v? I'm just marking down three velocities. So at this point, there will be a horizontal velocity, there will be a vertically downward velocity, and there will be a velocity which they are calling the resultant one. Okay. So and we are interested in the resultant velocity. And
Okay.
what will be the formula that we'll use for the resultant? Quick.
Um,
The Pythagoras theorem? No, remember? Because like if
uh,
you just draw the triangle, vector triangle, so it will be just the right angle triangle. Okay. Clear ना? इब्राहिम समझ रहे ना भाई?
yes, sir.
Perfect. And what will be our horizontal velocity? The initial horizontal was 20. Will that be at the final point?
Yes, sir.
Any reason for that?
Because there's no air resistance.
Very good. So no air resistance means no deceleration, so it will be constant throughout. Okay, fine. And what will be the resultant vertical? Sorry, what will be the vertical velocity at the final point?
We don't know it.
And can we manage to find it
Yes, sir.
by
With
using?
the equation of motion.
Very good. So now we know that the time is 1.75. Okay, we are interested in final velocity. Okay, just this variable is unknown. Okay, so we can use any of the equation of motion because we know four quantities. Okay, um, so I'm taking a is equals to b minus u over t. Okay, and a is 9.81 and t is 1.7 or whatever you're getting. Just multiply it with 9.81 and you'll get v. How much?
17.15.
17.15. Now you can apply the Pythagoras theorem and find the resultant velocity. That would be just 20 squared plus 17 squared, 17.1 squared. Okay, भाई समझ रहे हैं ना भाई?
Yes, sir.
Okay, perfect. How much?
26.4, sir.
Perfect, awesome. 26.4.
Yes, sir.
Okay, आ जाओ आगे आ जाओ.
Describe the difference between the displacement of the stone and the distance that it travels.
Mm-hmm.
Uh, the the distance is the amount of
Yeah,
is the,
just say it, bro. Um, the path that the stone takes, right?
yes, sir.
Actually, you have to make sure that the answer should be related to this diagram and not the general answer. Okay, so you're not allowed to say the
Okay, sir.
distance is the path taken by the object from starting point to ending point. This is the general statement which you can say or which you can write in your definition. Okay, and not here because they're specifying that you have to consider the stone's motion, right? And you have to define or just differentiate the distance and the displacement, right? So you can say that the distance is the path or track of the stone while the displacement. What will be the displacement?
That uh, this amount of space it
Okay,
moves like
the shortest possible. Okay, the shortest possible distance from this point to this point is the displacement. Okay,
okay, sir.
so while the displacement is the shortest shortest possible distance. So you're launching the stone from the cliff, shortest possible distance from the cliff to the sea. Okay. Right. Yeah. Cliff to ground. Okay. Cliff to the ground. Perfect. Okay. Let's move on to this question. Okay. This contain slightly. Okay. Just this is the easy one. Come on. Okay, let's try this one. Imad, your turn.
Two planks of wood AB and BC are inclined at an angle of 15 degrees to the horizontal. The two wooden planks are joined at point B, as shown in figure 2.1. A small block of metal M is released from rest at point A. It slides down the slope to B and up the opposite side to C. Points A and C are 0.26 meters above B. Assume frictional forces are negligible. Describe and explain the acceleration of M as it travels from A to B and from B to C.
Yes, Imad. What will you give as your explanation?
So give me 1 minute.
Mm-hmm. So the path of the block M would be this way, and then it goes on to this way. Okay.
Sir, from A to B,
Mm-hmm.
acceleration will increase.
Increase. And why you're looking at the slope, and that's why you are saying the acceleration increases?
Yes,
Bro, that is the velocity that will increase, okay? And not acceleration. Look, look, whenever you have any sort of acceleration to increase or to decrease, that acceleration required a certain external force, right? You are not applying any external force, any forward force, any pushing or something, and there are no resistive force or friction or something that opposes the motion, right? So neither you are pushing the block nor you are opposing the motion, so neither there will be the acceleration, the increase in acceleration, nor there will be the decrease in the acceleration. Okay, so there will be a constant acceleration. Okay, fine, is that clear?
yes.
This is the first point. Okay, this is the acceleration. Okay, and so from A to B the acceleration will be toward B. Okay, and it will be constant. So yeah, constant acceleration toward B, toward B. Okay, पहली चीज, toward B from A. Okay, then when toward B from A. Okay, so when it continues motion after B, then what will be its acceleration?
Sir, constant.
Okay, from B to C, B to C. Come on, B to C. The and what about the direction? From B to C, the magnitude of the acceleration will be constant, but the direction, yes, Ahmad.
Sir, opposite. Negative.
And why? तुक्का?
Sir, because acceleration is also quantity.
कोई नहीं. This is not the correct explanation, bro.
Sir, what?
This is not the correct explanation that you are giving. Like the acceleration is a vector quantity, okay. This means the acceleration should have some direction, okay. But why it will have the opposite direction? Why it will direct toward B and not C when its motion continue from B to C?
Sir, I don't understand
What? The question or the concept or both?
the what you
Both.
said right now.
Look, I am saying
I'm saying,
you said k from A to B the acceleration is just toward B, okay. और जब वो B से C की तरफ गया, so आपने बोला कि उसकी acceleration यहाँ पे आ रही है, right? The object is moving towards C, but its acceleration is actually directed toward B. Okay, this is what you are saying, right?
okay.
Okay, what okay वे? ये तुमने कहा है. Now my
Sir,
question
I didn't
is,
say this.
then क्या कहा फिर?
So I said from M to B the velocity increases, then from B to C the velocity decreases.
The velocity decreases, right?
Yes.
Okay. So if the velocity decreases, then so they're asking in terms of acceleration, right? So if the velocity decreases, then what will be the direction of acceleration in the portion of B to C?
So negative.
Very good. Because it is decelerating, right? Clear ना? समझ
Yes.
रहे ना भाई?
Yes. Yes.
Okay, perfect. Okay, move on to this part.
Calculate the time taken for M to travel from A to B.
From A to B. Okay. So is it a horizontal motion or a vertical motion or a both?
Sir, horizontal.
Okay, very good. It is a horizontal motion. Okay. So is it a constant acceleration motion or a constant speed?
Sir, constant acceleration.
Constant acceleration mean you have to use the equation of motion, okay? And for equation of
Yes.
motion, you first have to manage all the all those five variables, okay? Or at least three variables, right? Clear?
Yes.
तो अब क्या क्या कर सकते हैं हम? So now, if they are saying from the rest, so initial velocity position, okay. From the rest, so initial will be zero, and
Sir, max height. Max height.
max height. But bro, this is not the you're saying this is a vertical motion, right? This is the horizontal motion. So you have to consider the Planck's length, okay? And not the 0.26, okay? Just apply the trigonometric ratio to find the distance of AB. Getting?
Yes. Yes.
Okay. So that would be how much? Okay. So sine 15 is equals to 0.26 divided by hypotenuse. And hypotenuse will be 0.26 divided by sine 15. How much?
Um. Sir, one.
One. Just one? Heavy. One. Okay, fine. So we also know the displacement as one. Now, can we work out for the gravity? Yes.
Gravity.
Mm, okay, look. So actually the gravity acts in this direction, or like the acceleration, that is 9.81, acts in this direction, okay? If just the block is just falling, then the acceleration of free fall will be downward, okay? But the acceleration is moving at an angle, okay? Sorry, the block is moving at an angle, right? So you can make the component of the acceleration, right? So just break it into the vertical component and the horizontal component. Are you getting? Not getting? Yes, Imad.
Sir, what? Can you say it again?
देखो, आपके पास एक ब्लॉक है and the block is traveling at this plane, okay? And you know that there's a vector acting exactly downward 9.81, right? So but since you are moving on the plane, so you must have a component along the plane and a component perpendicular to the plane. That's what you want, okay? Like you should have a component in the vertical direction, okay, of gravity, okay, of the acceleration, okay, and you should have the component in the horizontal direction, okay, getting? Because we cannot use 9.81, the direction of motion of m is this way, so we must have the acceleration or a component of the acceleration is in this direction, okay? The rest of the component is useless for us, right? Getting? Am I samajh rahe?
Yes. Yes,
Okay,
sir.
so we cannot use 9.81 directly because it is not in the direction of motion. So yeah, so we should have to take अबे यार हटना. So we should have to take this horizontal component and not the vertical component as well. Okay, and now so this is the angle 15, 15, right? 15, yes. So this angle will also be 15. Okay, you can use math to prove that. Okay, we'll prove in the next chapter, don't worry. Okay, so for now you can just memorize it. Okay, whenever you have the inclined plane, then your angle inside and your angle of inclination will be same. Okay, so this is just 15. Clear? Now just make the
Yes.
component. So the that will be your vertical component will be 9.81 and cos 15. Okay, and 9.81 and sine 15. Okay, is that clear? Now we have that acceleration in the direction of motion, so we can use these three things. Okay, so we have the initial velocity 0, we have the displacement 1, and we also know the acceleration as 9.81 sine 15, right? And if we use 2as, no, if we use s equals to ut plus half at squared, then we can find the time. Okay, so we know the s is 1, we also know the initial velocity is 0, so this factor will be 0. And when you shift to that side, so just multiply it by 2 and divide by the acceleration, which we are getting as 9.81 sine 15. Okay, and just root all the values. Okay, so you can find the t. निकाल दो कितना आ रहा
Sir, 0.88.
है? 0.88. फाइन. गाइस किसी को मसला तो नहीं है? Yes, all of you. Yes. Are you guys understand this concept?
Yes, sir.
Okay. So now the third part says calculate the speed of m at b. Okay. Simple concept. M at b. So at b means just use the equation of motion again, and now you have four quantities, right? The time and these three quantities you can use um a is equals to v minus u over t. Okay, u is 0. So just multiply 9.81 sine 15, the acceleration, with the time, which is 0.8. Do you get 8.88 or 0.89?
Sir, 0.88.
88, okay, fine. So just multiply it with 0.88, so you'll get the speed.
Sir, you get 2.23.
2.23. Okay, just ignore 3 and that's it. Okay. Now, look, they're saying use the law of conservation of energy, right? They just make a little change by increasing the angle from 15 to 30, right? And they're saying use the conservation of law of conservation of energy, right? So even after this change of increasing the angle to 30, you can still solve this question using kinematics, okay? But now the restriction here is to use it with the energy method. Okay, so you have to use it with the energy method, you have to use the energy method here, but वो अभी नहीं पढ़ा हमने, which we will discuss in the chapter of work energy power, so you can skip that part, or you can try it using just the kinematics concept and just check the answer. If it's matching, then fine. Okay, so just skip it, and let's move on to the okay. Oh man. Okay, Irfan, your turn. Hey. This is a very simple question, right? A similar question we did it before, right? Okay, so you guys can try this at home. And let's move on to the this one. Come on. Everything contains graph, man. This is a vector, graph, 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 and graph, and no graph. Oi, oi. Okay, let's try this question. Yes, Irfan, your turn.
Yeah, okay.
Hmm.
A ball is thrown from point P with an initial velocity u of 12 meter per second at 50 degrees to the horizontal as illustrated in figure 2.1.
Hmm.
The ball reaches maximum height at Q. The air resistance is negligible. Calculate the horizontal component U.
Okay, so what will be the horizontal component?
It's a 12 cos 50.
Very good. 12 cos 50.
Okay,
Perfect.
just 1 second, let me do it.
Okay.
It's 7.71.
7.71. Okay, good. The vertical component.
It's just 12 sine theta.
12 sine theta. Okay, just calculate it.
What's the,
12,
I forgot the
12
angle.
sine 50.
50, okay. 9.19 or 9.2.
9.1. Okay, just 9.2. Okay, fine. The next one.
So that the maximum height reached by the wall is 4.3 meters. Sorry.
Hmm. Show that. You have to show that. Okay. The maximum height reach, which means you have to find the distance, this distance. Okay. They're saying that this distance is 4.3. You just need to prove it. Okay. So, will you use or will you take the vertical motion or horizontal motion
This
for this part? For the part B, will you consider the vertical motion or the horizontal motion?
won't it be vertical motion?
Okay, very good. Vertical motion, fine. So, vertical motion. So, for vertical motion, will you use equation of motion or the speed is equals to distance over time?
I mean, I think we have to use the equation of motion.
Okay. So, for equation of motion, we first have to find all like at least three quantities to use equation of motion. Okay, so the ball is moving up with the initial velocity of 12 sine 50, which we calculate as 9.2. Okay, and at maximum height, what will be the velocity at max height?
0.
Good, perfect. Zero. And the acceleration, please?
That'll be minus 9.81, right?
Very good, awesome, perfect. Good. So we have three quantities and we are interested in the vertical distance. Okay. Which equation you use? You don't, they don't give you time. So just code the equation that does not have any time.
Uh, just 1 second.
So actually you have 2as is equals to v squared minus u squared. Okay.
Yeah, okay.
Okay, just substitute the value. So S is a quantity we're interested in. So the initial velocity is the final velocity is 0 minus the initial velocity is 9.2 squared. And we have 2 times 9.81 with a negative sign. Okay. You can ignore that or you can just cancel the negative sign. So you just have 9.81 square 9.2 squared divided by 2 times 9.81. Okay. Yes, how much?
It is 4.313 at least. That's what I got.
4.31. Fine. 4.3. Sure. Okay. So, okay, move on to the other part, please.
Could you go back to
Okay.
the figure? PQ.
Acha, what will be the displacement? Can you mark the displacement from P to Q?
It's like basically, what's this? Displacement from P to Q. Since it's like the shortest distance, won't it be to like,
Straight
yeah,
line.
yeah, like that.
Good. Okay, fine.
Yeah, without the
So
curve.
so we are interested in this line from P to Q. Okay, and for that we should have the vertical which we found in the previous part, and we required the horizontal distance first. Then we can use Pythagoras theorem to solve for PQ, the distance PQ or the displacement PQ, right? So, for that we have to consider the horizontal motion. So we know the horizontal velocity as 7.7, right? And what will be the time? What will be the time for the horizontal motion, Irfan? Yes, Irfan. Where
I'm not sure
where will you
for
get the
time.
time? Okay. So for time, you can use the vertical motion, okay, and find out the time to reach the maximum height, right? And the time taken to reach the maximum height in the vertical motion should be equal to the time taken to reach that point horizontally, okay? Because the vertical and horizontal motion are simultaneously occurring at the in the same time frame, okay? So so we can use the equation of motion. We are just interested in time. I'm just taking VA equals to V minus U over T. Okay. And we have A as minus 9.81. Okay. We are interested in time. So just make time the subject. So initial vertical velocity, you have to consider vertical velocity. Okay. Because we are considering the vertical velocity, vertical motion to find the time of vertical motion. Okay. So 9.2 divided by 9.81, and it is moving up. So negative negative goes off. So this is your time. Okay. How much?
0.937. So basically 0.94.
No, just no, don't round off at this point. Okay. You are only allowed to round off your answer at the final point. Okay. Do not convert it in the intermediate steps. Okay. Otherwise, it will lead you to the incorrect answer. Okay. So just take 0.9. How much?
0.97.
0.997. Okay.
937.
937, sorry. 937. Okay, fine. So we have the speed, we have the time. We can use to find the distance by using speed is equals to distance upon time. Okay. So speed हमारे पास आ गई 7.7, time हमारे पास आ गई 0.937. Okay. So yes, how much?
7.2149.
7.214. Okay. So just square both the value and root it, you'll get the displacement. Okay. Allah. Yes, how much you are getting?
Yes.
Come on, bro, you are taking too long.
What do we have to square and
You just
do
need to
the
square. Look, we are interested in the hypotenuse, na? PQ. So you have to square 4.3 and you have to square 7.2, right? And this will be equal to PQ, the square of PQ, right? Then just root all the thing. Getting? Not getting.
oh yeah, okay, fine. It's 7.7 squared.
So you are saying it is 7.7. Okay. Let me check 20. It should
Oh no,
be, yes,
no, that's not the final value. You wrote d is equal to 7.7 into 0.937, but you're taking 7.2 in the 7.2 squared. Should be,
7.2 square, yes.
shouldn't it be 7.7 squared?
No, 8 minute. So like 7.7 into 0.937 gives you the horizontal distance. Okay, so the horizontal distance is 7.2, right? So this is
Oh,
your
okay, fine.
horizontal distance, right? This is
Yeah,
7.7 is the horizontal speed, right?
yeah. I'm getting 70.33.
And just root it
Yeah, after routing, I'll get
8 point something,
8.38.
8.3,
6.
8.4. Okay, very good, perfect. Okay, just one last question. Okay, you guys can try this one home. Contain graph, time taken, and the horizontal. Okay, fine. We can try this one. We can try this one. The last two, you can skip the last two part. Okay, let's try. Okay, Candy Bro, आ जाओ जरा.
Yes, sir.
आ जाओ जरा. Solve कर लो ये वाला question.
Displacement. Define one displacement. Displacement is the shorter distance between 2 points.
Wait, you should code the direction as well. Short as
In unit direction.
in wait, not a unit
So unit
direction.
direction
क्या मतलब यूनिट
in
डायरेक्शन. हाँ भाई स्पेसिफिक डायरेक्शन यूनिट डायरेक्शन यूनिट.
in a specific unit.
हाँ या इन अ सर्टेन डायरेक्शन या विद सम डायरेक्शन और फ्रॉम टुवर्ड द एंडिंग पॉइंट कुछ भी आप कह सकते हो राइट. अच्छा जनाब. So shortest possible distance in specified specified direction. Fine. आगे चलो.
Acceleration इसकी है rate of rate of change of velocity.
Rate of change of स्पीड लिख सकते हैं क्या स्पीड से काम हो जाएगा.
No, sir.
Velocity. Okay, fine. Very good. Okay, आगे आ जाए.
A remote control toy car moves up a ramp and travel across a gap to land on another ramp and illustrate and illustrated as illustrated in figure 1.1.
Fine. Initial velocity as 5.5 and this is just okay, fine. आगे आ जाओ.
The car leaves ramp P with a velocity of 5.5 ms minus 1 at the angle of theta to the horizontal. The horizontal component of the car's velocity as it leaves the ramp is 4.6 ms minus 1. The car lands at the top of ramp Q. The tops of both ramp are at the same height and are distance d apart. The air resistance is negligible. Show that the car leaves ramp P with a vertical component of velocity 3.0 ms minus 1.
Okay, fine. So here is your car and this is your resultant velocity and this is a horizontal component 4.6 and they're asking for the vertical component. Yes, what will you do?
Sir, vertical.
एक नंबर दे रहा है, एक नंबर, so it should be very easy question. Okay. Yes. Come on. कहाँ गया बे? 5.5, 4.6, and you're just interested in this length. That is like this vertical, okay? So just take 5.5 squared is equals to 4.6 squared plus VV squared. So just do 5.5 squared minus 4.6 squared is equals to V and whole thing under root. Getting? समझ रहे हैं ना भाई? इस बेचारे का नेट ही मर गया. So 5.5, 5.5 squared plus minus 4.6 squared and under root it will get, I'm getting 3.0. 3.0. Fine. Okay, G. Determine the time taken for the car to travel between the ramps. Okay. Yes. Can anybody tell me? Uh, Candy back? Yes. Bro, did you get the first part? Yes, Candy Bro, समझ में आ गया? पहला पार्ट आ गया समझ में?
सर
पहला आ गया समझ में?
हाँ जी सर.
पक्की
वो
बात है
सर
ना?
लाइट चली गई थी.
ओके ओके. सही. बस एंड हम भी एंड करने लगे. जस्ट दिस इज द लास्ट क्वेश्चन ऑफ द क्लास. ओके, डोंट वरी. सो अच्छा, ये समझ में आ गया. ओके, आ गया. जो डिटरमिन द टाइम टेकन फॉर द कार टू ट्रैवल between the ramps. Yes. What concept you use? जल्दी.
सर अगर हॉरिजॉन्टल है तो स्पीड इज इक्वल्स टू डिस्टेंस ओवर टाइम.
ऐसा बोल रहे हो?
सर ऊपर जरा दिखा दें.
देखें. We have the horizontal distance, but we don't have the horizontal time. Okay. And we don't have the horizontal distance. We just know the horizontal speed. So we horizontal motion won't be that much useful for us. You can use a vertical motion though, right?
सर तो सुवर्ट इक्वेशंस लगेंगी.
है लगा देते हैं आओ. So we have the initial vertical velocity as acha. I'm considering half of the vertical motion. Okay, I'm just considering the motion from this point to the max height so that I can easily take the final velocity as zero. Okay, then whatever the time I get, I'll just multiply it by two to get the full time. Okay, समझ रहे हैं ना भाई?
यस सर.
So initial vertical velocity is just 3.0, right? Final velocity is 0, and A is negative 9.81, and it is moving up, and we are interested in time, so we can just use A is equals to V minus U over T. So just shift T this side, and you do have to divide minus 3 by minus 9.81, so you'll get the time and just multiply it by 2 to get the full time. So that's it. Yes, how much you're getting? 6 divided by 9.81 should be around point point
सर मल्टीप्लाई बाय 2
5
करके 0.611.
0.611. Fine. आगे आ जाओ भाई. The
Calculate the horizontal
horizontal.
distance d between the tops of the two ramps.
Okay, so you can use time as 0.61 because time for vertical and for horizontal motion remains the same. And you can actually you know that the horizontal component of the velocity is 4.6, so you just need to find d. So v equals to distance over time, okay, and just multiply the distance, just multiply the speed 4.6 by time, you'll get the distance. Okay, yes, how much?
Sir 2.8.
2.8. Perfect. Now that's it. Okay, so that's it for today's class. Okay, guys, you have to complete the MCQ worksheet first. Okay, the 3.1. And then I'm sending you this worksheet. Okay, it approximately you just need to cover like 2 to 3 questions. Or okay, for now skip the graph one and do the rest of the question. Okay, and then what the hell? Okay, and then um acha, try this one. Okay, this is a difficult one. 33 question is a difficult one. Okay, so try that one. And okay, fine. After that, I'm also sending another worksheet containing just 15 or 17 MCQ regarding the projectile motion. Try those out as well before the next week. Okay, so for the next till the next week, you have to complete the 3.1, the MCQ worksheet, जो कि मैंने पहले से दे रखी है, right? So you have to complete that, and I will be sending another worksheet regarding the projectile motion MCQ based, and this is the structured question that you have to complete. Okay, just try all those questions that does not have any graph. Okay, if there's a graph, just skip it. Or if there is a kinetic energy or some energy concept, then do the question from start to that point and then skip it. Okay. So this is your homework for the next week, and inshallah, in the next week we will complete the kinematics, and probably after that next week I'll be taking the test of the kinematic. Okay. So be prepared. Okay. So चलिए बस अब आज के लिए इतना ही था. We'll meet you guys in the next week. Okay. Till then, take care. Allah Hafiz.
Laugh.
Allah Hafiz.
Allah Hafiz.
Allah
Allah.
Allah Hafiz. Allah Hafiz.